Welcome back to Lesson 1. Here we're going to review our primary trigonometric ratios, sine, cosine, and tangent. Now in order for us to use our trig ratios in a right triangle to help us find missing angles or side lengths, then we need to know how to properly label a triangle. So say this is angle theta here. Theta is just the symbol we use to represent a missing angle, just like we use x to represent a missing side length. Now the side that's across from the 90 degrees is called the hypotenuse, just like in the Pythagorean theorem. The side that's across from the angle theta is called the opposite. And the side that's next to the angle theta is called the adjacent. Now the hypotenuse is always going to be across from the 90, but the opposite and adjacent are going to change relative to the angle. So for example, if theta is up here, this side will still be the hypotenuse, because that's across from the 90. But now the opposite moves down here, and the adjacent moves here. And we need to label the sides so we know which trig ratio to use to help us solve our problem. So we know that sine of theta is equal to the opposite side over the hypotenuse side. So if you're given those two side lengths, you would use sine. And you can write that as O over h for short. Cosine of angle theta is equal to the adjacent side divided by the hypotenuse side. And tan of theta is equal to the opposite over adjacent. Now one way to remember these three trig ratios is something called SOHCAHTOA. SOHCAHTOA. The way this works is you say sine is equal to the opposite over the hypotenuse, cos is the adjacent over the hypotenuse, and tan is equal to opposite over adjacent. So let's look at example 1, where they want us to label the sides of each triangle as the opposite, adjacent, and hypotenuse. I always like to start with the hypotenuse, because that one's across from the 90. So this one here would be h. The one across from the angle, we say that that's the opposite, so we'll say that's O. This one here next to it is called the adjacent, A. Now for B, the hypotenuse will go here. The opposite will go up here, and that's the adjacent. For C, here's the hypotenuse, opposites down here, this is the adjacent. And for D, here's the hypotenuse, here's the opposite, here's the adjacent. Now in example 2, they want us to determine the sine, cosine, and tan of theta for each triangle. So let's start by labeling the numbers here in A. The 5 would be the hypotenuse, the 4 is the opposite, and the 3 is the adjacent. Now remembering our SOHCAHTOA from the previous slide, I know that sine is opposite over hypotenuse. So filling in the numbers, I get 4 over 5. Cos is adjacent over hypotenuse, so that is 3 over 5. And tan is opposite over adjacent, so that is 4 over 3. Now for B, let's say 25 is H, 7 is O, and 24 is A. So sine would be 7 over 25. Cos would be 24 over 25. And tan is going to be 7 over 24.